We're going to talk now about endorphins, which is known as the morphine within. It is as I say, natural opiate-like neurotransmitter linked to pain control and to pleasure. Endorphins naturally occur in your body, and I guess you could say they're what make you feel good when if you've cut yourself and then all of a sudden, if it's like a paper cut, and then all of a sudden you notice a couple hours later that, wow, I forgot about that paper cut, and until maybe you put lemon juice on it or something on accident. But the reason you don't feel it all the time after the cut and just for a little while afterwards is endorphins are released into your body that make the pain go away. And it is like opium. Opium is and we'll get into a lot more of this in the drugs chapter, but states of consciousness. But morphine is a derivative of opium. Okay, so opium comes from the poppy seed. Morphine actually has a medicinal use, and heroin is the other form of it. It has no medicinal use. It's basically made by people who are trying to make recreational drugs. So there's, I guess, it's not as clean as morphine. But of course, you've heard, like in war, soldiers are given little morphine, little tiny vials of morphine, several of them to carry, each soldier, because when you get shot in the field of battle, you many times you don't have somebody close to you to pull your friend away or something, and if they have a huge wound in them and they're either they're in a lot of pain or they're in pain and dying very fast, people don't want to listen to their friend die in pain and so on and so forth, or they want to help calm them down, and they just take these little vials and they break a little plastic top off, and they have a little needle, and they just jab it in the arms, or usually the thigh or the butt, and morphine, boom, goes into the system. It doesn't take much. Now, if you've ever seen any of the movie shows about battle, they'll write a little M on the head of people. They'll use blood, usually write M, saying they already gave this person morphine. You don't need to give them more, because you can actually overdose people on morphine. Okay, so anyway, little tangent there, but endorphins make you feel good. They are also what is released when if you've ever heard of a runner's high or a swimmer's high. When you really have had a heavy workout and you really tore your body up, your body knows, your mind knows, hey, this is going to hurt. There's going to be some aches and pains here. So it floods the body right after the workout with endorphins, and you sort of walk around like, hey, I can walk through walls. And having been a swimmer before, a competitive swimmer, I know this feeling, and I'm sure those of you who do anything like this know that feeling where all of a sudden you get this point where you've worked out so hard, all of a sudden it's like your body just feels like you're the Hulk and you can just do anything. But you can't. You're human, and you're not green. All right, so the next little term there is the nervous system. It's basically the body's speedy electrochemical communication system. Okay, the key thing here is it's fast. The nervous system is fast. Consists of all the nerve cells of the peripheral and central nervous system, which we'll learn about here in a moment. And hopefully you've already kind of learned about that in biology. Now, what are nerves? Nerves are cables, so that's saying it's lots of neurons. Think of it like a suspension bridge where they have the wires holding up the bridge, and they start with very small metal wires, and they just keep wrapping them around each other, and then they take a little bit bigger wires and wrap them around each other, a little bit bigger wires and wrap them around each other, so they have a big, giant, like I don't know, 1 inch, 2 inch thick steel wires that help hold up bridges. Okay, I'm sure they're bigger than that, but that's what nerves are. It's the same thing with nerves as taking neurons and doing that. Okay. Now, neurons have the ability to make new connections. So when you hurt yourself, when your brain has some damage, especially when you're younger, you have this concept that's called plasticity. The brain can rewire itself with neurons. Okay. In other words, pathways that helped you do something before, even though they may have been destroyed or injured, you can create new pathways, which is kind of cool. So if somebody has a stroke, that's the best image I have of it is when a stroke, which is basically a blood vessel breaks in the head, in the brain, and you have bruising, you know, all kinds of, you can have all kinds of different damage done by a stroke. But some people forget, they usually go into a coma for a while, but when they come out, all of a sudden they can't walk. Part of the brain that helped them walk, they can't do it. And there's been nothing physically done to them. They haven't gotten in a car accident or anything. They just got a stroke. Well, they can relearn to walk. They have to put the time in, they have to work at it, but sometimes it takes 6 months, 8 months, something like that. And these people can, if the brain isn't too damaged, they can relearn to walk. And what that is their brain is literally taking that much time to rewire itself to teach them how to walk again. So pretty cool stuff, but again, I hope nobody has to go through that. All right, now we're going to talk about agonists and antagonists. All right, this little picture right here, you need to learn this. Learn it. I'm going to go over it again in class, but it has to do with how neurotransmitters work, okay? And then how drugs work. How do drugs come into the body and either make you have a feeling or don't make you have a feeling, okay? An agonist is a substance that acts like another substance and therefore stimulates an action, okay? And then an antagonist is a substance that acts against and blocks action. So if you look on here, I'm going to use this little, my cursor here. This is the actual neurotransmitter. It binds perfectly, as you can see here with its receptor site. It looks exactly like it, binds, boom, and you get a perfect action. So when you're just using the drugs in your body, you don't have side effects because there's nothing wrong with the neurotransmitter. It's perfect. Now, on the second one, you have an agonist. So this is the kind of thing that looks is very, very similar to the original neurotransmitter, but it's not quite the same, but it's close enough that it gives you the same feel, sort of like what morphine is with epinephrine. I'm sorry, morphine is with as an endorphin. Okay, it's close enough that it gives you the same sensation, and actually it can actually be way higher with morphine, give you that sensation a great deal more. But because it's not exactly what your body's used to, there's going to be side effects, which of course come with you have the high that goes with taking morphine, and or you're going to have all kinds of physical things. It could be diarrhea, it could be weight gain, it could be dry mouth, there's headaches, the list is endless, okay? Then you have this third version, which is an antagonist, and it stops basically the natural neurotransmitter from binding with the receptor site. And it's not enough like the neurotransmitter to make something work, okay? And so it's actually going to prevent the neurotransmitter. All it's doing is preventing a neurotransmitter from binding with the site. That's where the, what's the word? And I apologize, I'm just drawing a blank here. Botox, that's basically injecting poison into your face. So, I mean, what it's doing is it's taking botulin, okay, which if you ate it, it could kill you, okay. But if you take botulin, and everybody's worried about the wrinkles right here. I'm not worried about it, but some people are. Of course, I'm aging well. But when you inject that in here, what it's doing is preventing the muscles it's relaxing the muscles and preventing the muscles to tense, okay? So it's actually what it's preventing is ACH from doing its job. And by preventing ACH from doing its job, the muscle can't move. That's why some people get that stiff look when they have just gotten Botox. And it's blocking ACH from doing its job. It can bind with the site, but it's not imitating ACH, which is acetylcholine. So if you have questions, please bring these up in class, and we will go over this again anyway. So moving on. Going back to the 3 types of neurons, again, just trying to make sure you understand. You've got the sensory neuron, the interneuron, and the motor neuron. I just added this slide because I like the picture. And you already have this, but it doesn't hurt to learn it again. Now we're getting into the central nervous system and the peripheral nervous system. Central nervous system, very simply put, is the brain and the spinal cord. That's it. So it's just brain, and then what comes straight down from the brain, and that's central. It's centralized in the body. Peripheral is all the stuff out away from the spinal cord. So from your shoulder out, your arms, your legs, your feet, your hands. Okay, that's your peripheral, and the job here of the peripheral nervous system is to sense the world and help you survive. Okay, and then you have the breakdown here of the nervous system. You have I just told you central, peripheral, and then the peripheral breaks down into the autonomic and the somatic. Okay, and then again the autonomic breaks down. Autonomic meaning automatically controls things. These are things that you don't want to think about. Your heartbeat. You don't sit around going beat hard, or work kidneys. Thank God, because I know I'd be dead. My memory is so bad, I'd forget to have my own heartbeat. But it happens automatically, okay? Those are automatic functions. Somatic is voluntary movement. So that's anything like, I'm moving my fingers voluntarily here, or I'm talking, it's voluntary. So then you have autonomic that breaks down into sympathetic and parasympathetic, okay? And I'm going to hold up just a second. I'm going to go to this next slide so you can at least see this for skeletal and autonomic. And then we're going to talk about sympathetic and parasympathetic. So the sympathetic nervous system, okay, this is the part of the autonomic nervous system that arouses the body. This is what says, get moving, dude, fight or flight. So it releases adrenaline and non-adrenaline, increases heart rate, blood pressure, blood flow to the skeletal muscles, it inhibits digestive functions. So it's all about survival. So if you are in that moment, let's say you're walking through Oviedo, you're walking through Oviedo, minding your own business, and out from a bush should jump the feared Oviedo tiger, okay? Because we're not afraid of lions here, we're afraid of tigers, okay? So it jumps out. Well, you're like, a lion, or a tiger, not a lion, a tiger. And when you're afraid of it, what's happening is a lot of natural things are going on in your body. It's not left up to your choice. Your heart rate goes up, mostly because you want to react faster. More blood flowing, the faster you react to the tiger. Your eyes dilate so you can see better. Okay, and another side effect, if you have just eaten a meal, your body determines whether you like it or not. Time to get rid of this meal, because I don't have time to be digesting a meal and running away from a tiger. Okay, so you throw up. Your body will force the vomit. It comes out as vomit, but it forces the food up and out, and so that you're primed to have the max capability to defend yourself or run or flee from a situation. If it was really a tiger, you probably are in trouble, because if you flee, it's going to run you down and kill you, and if you stay and fight, it's going to kill you. So let's just hope there's no loose tigers in Oviedo. All right, moving on. Then once you're all done and you've gotten away from the tiger, let's say you did outrun the tiger, and that must be a three-legged, two-legged tiger. But anyway, your parasympathetic nervous system starts to come into play, and you got to calm back down. And so these are all the things that it's basically the rest and digest system. So your body, your eyes go back to normal. Your blood flow back to your stomach occurs again. You'll get hungry again. All the stuff that is basically the normal part of your normal day starts operating again. All right, so that's that. And we'll go over this again.